Final review, question number 15. A tower stands 113 feet tall on a hill with a slope of 34 degrees to the horizontal, as depicted in the diagram below. A guy wire, support wire, is to be secured from the top of the tower to a point 98 feet uphill from the tower's base. Determine the length of the wire required. Round your answer to the nearest tenth. So to see this picture better, I'm going to make it into an abstract shape. So it is the hill, here is 34 degrees. The tower is gonna stand like that. It's not standing at a 90-degree angle. It's going to be a little bit less than. So that is the wire. I'm gonna say this is W. This is 98 feet. And this is the length of the tower, which is 113 feet. Now, we're going to use, since this is not a right triangle, this is not a right triangle right here, we're going to use the law of cosine to find this length. And we already have two sides known, so we need to know the angle in between them. In order to find the angle in between them, I'm going to use the properties of parallel lines with a transverse. Here is the transverse here. We know that the alternate anteriors or angles are equal, so this angle is 34 degrees. And we also know that this angle right here is going to be 34 degrees. Notice how this forms a 90-degree angle with the tower, which means to figure out this angle in between the known sides, we say 90 minus 34 degrees, which is equal to 56 degrees. So this angle is 56 degrees. Now, we know that W squared is equal to 98 squared plus 113 squared minus 2 times 98 times 113 cosine the angle in between them, which is 56 degrees. If you do the math, make sure your calculator is set to degrees, not radians. W squared is equal to 12,769 plus 9,604 minus 12,395.6 approximately. And that will lead to 9,977.4. If you take the square root, you get W. Square root of 9,977.4 will give you 99.9 feet, which is the length of the wire. So that is how you solve this type of question.